In this lesson, we're going to go over looping specifically. Specifically, we're going to talk about while loops and for loops and exactly what those different types of loops are and when to use those different types of loops. Hopefully, you don't go too loopy while we try to go through this, but in the end, I promise you, it's going to be a lot of fun. So let's get started with loops. Exactly is a loop? Well, you can think of a loop almost like an infinitely looping GIF, right? So an action happens, and it happens over and over and over and over and over again. Well, a loop is essentially that. It's a set of actions with a set defined starting and closing actions. The starting and closing actions doesn't necessarily mean that it has to have a stop. Right? So the closing action could actually be run forever. You never stop. And so you kind of have to think about that. Well, so there's for loops, which is a type of loop that iterates over a sequence of objects. We explored that very quickly with the tuples. So we were iterating over each element inside of the tuple. While loops, however, they continually loop until we have a specific exit criteria. So with for loops, we have a start and end. With while loops, we have just a go and then terminate when a certain condition happens. So let's start talking about how to work with these. Let's start with a while loop. So I'm going to switch over to my module 5, and I'm going to create a new folder called loony loops.py. Now remember, if dunder name is equal to dunder main, and start working with this. All right, so let's see here. We can do something interesting. Let's create a set of vowels. And that's going to be equal to A, E, I, O, and U. Like that. Now, something interesting about all data containers is they have this thing called length. So we can use len to determine the length of that. And let's print this out here just to kind of show you what that is. Loony loops. So we can see that this has a length of 5. So 1, 2, 3, 4, 5. Now remember, index is 0, 1, 2, 3, 4. Because Python is always a 0 index system. So we can actually use that to our advantage. Let's create a while loop. So I'm going to set I equal to 0. And then while I is less than the length of vowels, then I'm going to print out vowels of I like this, and then I plus equals 1. So this is an interesting another set of operators that you probably haven't seen before, the plus equals. The plus equals is the equivalent to this. I equals to I plus 1. And there. By just doing plus equals 1, you're basically taking the previous value of I, add 1 to it. And that's all you're doing. The same thing that's in there. Okay, let's run this and see what we get. A-E-I-O-U. So there we go. We've iterated over that. So all loops have the same structure. You have the loop name and then its conditions. Now in while loops, it's a while and then whatever condition equals true, And then as long as that condition continues to equal true, it will continue to loop. So in this case, I is less than the length of vowels, which is 5. Let's visualize this a little bit and let's execute this. So we're going to debug this like this. A Python file. We're going to run this, and I'm going to set a watch here and see what is the length of vowels. Okay. So length of vowels is 5. Vowels is this. So now I up here is 0. Now let's iterate through this. So while condition, that's in there, then colon, okay? And the colon is really important for that. We use it up here in our if statement, and we're going to use it with our for and while loops that's in here. This tells Python that that's the end of that while loop declaration, essentially. So while this condition is true, let's do that. So let's actually do that. I is less than length of vowels, like that. So this is true in there. Since this is true, we're going to go and execute the contents of this while loop. So let's go ahead and start doing that. Well, we're going to print the first item, which is A. We're going to iterate, or we're going to add 1 to I. And you can see 1 change, or 0, sorry, I changed from 0 to 1. There we go. Is 1 less than 5? Yes, it is. So let's do that again. Boom. We have E printed out, and now I is equal to 2. Is 2 less than 5? Yes, it is. Let's do that again. Oh, 3. And 4. And now 5. Is 5 less than 5? No, it's not. That means we're done. What were to happen if I took this out? What if I didn't increment 1 or increment I? Let's find out. So here we have I is equal to 0. Is I less than 5? Yes, it is. Let's print out vowels of I. Okay, we've printed out A. Now next, is 0 less than 5? Yes, it is. Now let's print it out. A again. Let's keep doing this. Well, as you can see, it's just printing A. Nothing's really happening other than that. And here's a question. Will it end? Well, it's running right now, and it's printing a whole bunch of A's. And the answer is, nope, it won't. So that's one of the dangers, or maybe advantages, of a while loop. You can create conditions where you are constantly running, infinite looping. And that is possible. Now, let's look at finally this anatomy of our while loop. So we have while, our condition, and then our colon. And then the body of the loop is indented 1 level there. Now that level can be either tabs or spaces, but you can't mix tabs and spaces. So let's talk a little bit about tabs and spaces. So tabs and spaces are used to mark indentation levels. It's really important in Python. Tabs and spaces is also one of those extremely controversial things that you're going to find inside of any type of developer. The advantage to using tabs is, well, it uses less space, technically. Though with today's computers, that's somewhat almost negligible at this point. That doesn't mean that tabs are bad, but to say that it takes up more space, I would say that that's probably not the greatest of arguments there. Spaces, definitely make sure that you have indentation as the same. In fact, tabs can actually be rendered differently. So you can have two tabs. You can have tabs that render either 2 spaces or 4 spaces or 8 spaces or 16 spaces. You can have it however you wanted. That can be represented in any way. But if you use spaces, a space will always be that way. Python 3 doesn't allow you to mix the two. You can't do tabs or spaces, so you have to pick one. I personally go with spaces because that's what PEP 8 suggests, and they suggest using 4 spaces. Or you can pick tabs that render at 4 spaces. But I'm just personally a fan of spaces. If I see you submit your homework or submit a review to me on GitHub and you're using tabs over spaces, I will only silently judge you. I will not actually say anything about it. So that's my opinion. Use spaces. But indentation is extremely important in Python. And you can see that here. So because we're under this if statement, this main statement that's in here, we're already indented by one level. And we've got to indent an additional level for the while loop that's in there. So that's what we have to do. Okay. So that is essentially a while loop. Now let's look and examine what the for loop looks like. I'm going to fix this here. And then I'm going to comment it out. And let's talk about the for loop. So for letter in vowels, print letter. Let's run this. Oops. I don't know why it keeps getting out of there. A-E-I-O-U. There we go. And there we have it. And that printed. Kind of a little bit more simpler than this, than the while loop. It's fairly easy because you're doing letter in this container. And so what this does is this will go through each of these items and change the variable letter to be the value of each of those items inside of the data container. So for each iteration, letter becomes this value that's in there. Let's look at this in our debug. So we iterate and look over here. We have vowels, which is the A-E-I-O-U. And then we have letter, which is A. Now we're going to print that out. And now letter becomes E. Print that out. And now letter becomes I. And then O. And then U. And then we're done. So the advantage of using the for loop is it's great for finite sequences. When you know that what you're going to be iterating over is going to eventually, it will have an end to it. So you're looping over something. Data containers are perfect for using for loops with. That doesn't mean you can't use a while loop. I showed you how to do that. But while loops are actually more intended to be used for situations where things don't necessarily have a specific length, or you don't know how long they're going to be, or you want to be continually iterating over or continually looping. For example, whenever you play, say like a video game in there, there's a while loop going in the background, and it's constantly going, and it's waiting for a reaction. So let's say you're playing a first-person shooter, right? And what it's doing is it's constantly looping, waiting for you to make an action. So when you move the mouse, it sees that, it checks that, and then it determines, okay, it moved. How much do I need to move the animation on the screen? That's constantly looping there. And so that's exactly kind of the type of situation that you're doing that. Let's say you're a web server. a web server, you're always constantly just listening. And as soon as somebody connects to your web server, oh, there's a connection. I need to serve up web pages and do all these different types of things. They typed in a search. Oh, I need to go and trigger based off of that. So that's kind of what a while loop does, is when you don't necessarily know when something's going to happen, you need to be constantly running, or you're kind of unsure how long whatever it is that you're working with is that size might be. So that's the advantage of doing that. There's something else that I kind of want to show you, and that is the range function. So for I in range 10, print I. What does this do? Well, what the range does is it generates a range of numbers. And if you put just one value inside of that range, it's going to be 0 to the number before that range, meaning that it stops at 10 but doesn't actually assign I to the value of 10. There we go. So there you go. You can see 0 all the way to 9. Now, technically, you can also do a start and stop. So the start would be 10, and then let's say our stop is 20. The same thing applies. Your start is included. Your end is not included. So we should expect to see this to go from 10 to 19. And there we go. Well, you can see that. 10 to 19. Now there's an even additional more input, which is the step. And what that step is, instead of it stepping, one number each time, now do. So let's run that and see what that looks like. So now we got 10, 12, 14, 16, 18, and not 20, because we don't include 20. If we did want to include 20, then we would have to do 21. And now we've got 20 included in there. So there you have it. That is how you use the range function and work with that. The next thing that I want to share with you is nested loops. So what does a nested loop mean? Well, let's do I in range 5, so 0 to 4. And then for j in range, let's do 5 to 8. And then we're going to print this. I equals I and j equals j. Now, before I execute this, I want you to sit there and I want you to think about what exactly is this going to do? So if we have an iteration here and we're going this way, so we're going to have an iteration of I into here. So I is going to equal to 0, then 1, then 2, and then all the way to 4. And once it gets down to that, it's now going to say j from 5, 6, and 7. So what numbers will be printed out? Will we have 0, 5, and 0, 6? Or will we have 0, 5, 1, 6? Or will we have 0, 5, 6, 5, or sorry, 0, 5, 1, 5, like that? Think to yourself, what do you think, what makes sense to you of what this should be? Let's run this and see if it matches what you think it should be. So we've got 0, 5, 0, 6, 0, 7. then 1 5 1 6 1 7, then 2 5 2 6 2 7. So what's happening here is this. Let's run it and visualize what's going on here. So we've got I over here is 0, and J is 5. Print out our statement. Now we continue with this for loop inside of this for loop. So we do this, 6, 7, and now we finish that iteration. We back out and start the next iteration of this. We increment I, and now we go through this all the way through until we reach the end of our script. And there you have it. Okay, so that is kind of loops and nested loops. You can actually do something before and after a nested loop. So let's see, a print here, nested loop. And then print post nested loop like this. Let's run this real quick. And you can see, okay, before we did this loop, before we did the nested loop, we print this out, and then that gets printed all out inside of there, and then we have some post-processing. And so this is typically what's going to happen when you're doing nested loops, is you're probably going to do some sort of iteration and do some calculations, then do an set of iterations underneath that, and then finish up your calculations or post-processing that's in there. So this is all there is to, well, not all there is to know about loops. There's a lot more to know about loops, but this is a good start to understanding loops. Take some time and really kind of ingest this and play around with this. Change the different values of the range, or pass in a different string to iterate over, or create another tuple with a whole bunch of different stuff, and just kind of play around with loops and see what kind of happens, and see how you can kind of manipulate this in multiple different ways. Next up, we're going to talk about lists and what that means and what exactly is a list.